Hey, what's going on, everyone? Hope you're all doing well. Let me just go ahead and open the file that I wanted for this tutorial. Our tutorial today is a customer payment analysis application. So that's the CSV file or Excel file, really doesn't matter. So yeah, today I'm going to share with you a hands-on data science project, which is really perfect for beginners and built to feel like a real business case without needing any real company data. So I'm going to talk about the idea of development of this application a little bit later. Yeah, basically, this is a customer payment analysis tool. It's going to walk through the whole pipeline. I mean, we're going to load this data that you see on the screen. We're going to inspect it. We're going to clean and transform the three main dates that we have here. The invoice date, let me just maximize a little bit. This invoice, the invoice date, the due date, and payment date, those three dates. And the main thing here is to analyze the key payment matrix through the KPI or the key performance indexes. We will have four of them. And we're going to print them just to the console. It's really a simple application, and I'm going to talk about it a little bit in a moment, actually. But also, I'm going to visualize insights with plain Matplotlib. We're going to use Matplotlib for this. So the project actually grew out of a tool that I built at work, and I was building this with VBA, Visual Basic Applications for Excel. So I created this macro to automate some SAP or SAP extractions. So what I was doing actually is that I was extracting some data, customer data or customers data, a lot of customers. And I have this SAP extraction in the form of Excel file. I would feed the tool this extraction that I have from SAP, and just you click a button and it does the analysis and you have your report, which is essential for our monthly or semi-monthly calls with the management. So we needed to know which customers have problems in payment, who always pay late, what are the reasons for that, and what are the actions and measures that we can take in order to prevent that in the future. I didn't have any sort of visualization because, as you know, Matplotlib only is a library for Python. VBA is really limited to the extent of Excel sheets. You can automate, you can basically you can automate everything in Excel using VBA, and it's basic language, Visual Basic or basic language, which was my first language, by the way, in the 80s. Here I have just swapped the SAP data for a simple CSV file. Basically, CSV, Excel, really doesn't matter. It's the same thing. These are dummy customers, so none of this is real. And yeah, so we can share and experiment together. It's 100 lines probably. Yeah, 101 lines. 100 lines minus the header. So yeah, that's basically it. We're going to work with Python only, and yeah, hopefully that the camera is not moving. I've changed the setup. Now I'm working only on my laptop, and I'm looking here to my iPad, and I'm just, for the material, I'm just sharing with you how I'm recording this video because that's the first time that I use that setup. So in this tutorial, we're going to explore overdue amounts, payment delays, and even we will train a small logistic regression just to predict the late payments, which I find very important and useful, especially when you have those types of calls with the management and you need to explain if you're a team lead or process lead, for example. This tool is very important. This tool is very useful. And this kind of analysis, why we have late payments and how we can predict those late payments, I find it crucial and very important. If you're a team lead or a process lead, you need to explain to the management what's going on and what can we do to prevent those late payments. We can do, for example, pre-dunning. So maybe I didn't explain that before, but I work in the accounts receivable department in my company, and we do cash collection. So our primary task is to collect money from the customers. And it happens a lot that a lot of customers, they don't pay on time, which is a very recurring problem. It happens very often. So you will need to be able to justify why the customers on your portfolio or globally they pay late. Not all of them. We're going to choose maybe the top 10 or top 25 or top 5. Depends on the size of the company, really. There is no one standard template that you can use for all of the cases. So I believe that this, you're going to find, by the way, the link to GitHub repo in the description below. You can go ahead and clone the application on your computer and use it as a template. You can change and tweak in the code according to the data that you have. There's no problem. And if you have any issues, you can check out with me, or you can check out together, guys. We're building something nice here. And as I was always saying, that programming is for the joy of programming. We're not building the next Facebook or the next, Instagram. We're just doing useful stuff that we really can use in real life. So this application is a real life application, and I hope it will be useful for you if you need that kind of tools. Yeah, we're going to use a single Python script. I'm not going to use Jupyter or Anaconda or any of that. If you want to use this, go ahead, feel free to open Google Colab, for example, or a Jupyter Notebook. But for the sake of simplicity in this tutorial, I'm going just to use plain Python file. And that's it for the introduction. Thank you so much for tuning in. If you're watching me for the first time, don't forget to subscribe. Hit the like button if you like the video at the end of it. Give me your feedback, your comments. Your suggestions for future videos are very much appreciated. And without further ado, go ahead, grab your cup of coffee if you want, or your cup of tea, prepare your keyboard, open your code editor, and let's get started. All right, guys, so let's go ahead and create this folder. I'm gonna call it CP, customer payment, simply. Yeah, you're free to call it whatever you want. And first of all, I want to activate the virtual environment using pipenv. Now you can use virtual environment venv, pipenv. It really doesn't matter. There are no big problems between the different operating systems. So if you're running on macOS, on Linux, or on Windows, like I am doing, it's going to work almost the same way. So simply you would do pipenv shell. If you don't have it, you will need to install it. Pip or pip3 install pipenv, and then you can activate the virtual environment. And activating the virtual environment inside your folder or your projects folder is very important, as we're always saying, because it prevents the mixing of different versions of the dependencies that you install inside your project with the other versions or the main version on the global file system. So that's very important. By default, that exists in JavaScript. In Python, you need to activate a virtual environment. So now we have our virtual environment activated. What I will need is, let's create our requirements file, requirements.txt. Also, let's have our main file, main.py file, right? So we have here the pip file for the virtual environment, the main.py, and requirements.txt. Let's open the requirements.txt, and let's add only three dependencies. Pandas, NumPy is going to be installed if your system will detect that you don't have it. So we need pandas, we need scikit-learn, and finally I need matplotlib, right? Matplotlib, pandas, and scikit-learn or scikit-learn. Awesome. Let's save that and let's just minimize a little bit. And let's do pipenv install -r requirements.txt. That's going to install all of the dependencies inside your folder. So what we're going to do actually, the first thing that we're going to do is we're going to load the invoice data. So we'll need to find the path for the project. And by the way, we'll need to open this with Visual Studio Code, and I need to copy this file right here, the dummy invoices. We need to copy that to our folder. Just we'll wait until the installation of the dependencies is done, and then we're going to copy it to our folder. All right, awesome. Now let's open this with Visual Studio Code. As always, you're free to use PyCharm or any code editor you like. Now we have our main.py. We have here the dependencies. Everything is installed. We have everything from pandas, scikit-learn, and matplotlib. Let me open that like this. Yep. It is working. It is working. Perfect. Right, okay, so let's go ahead and start coding our application. The first thing we will do, as we always do, is to import the dependencies. But here I'm going to import the standard dependencies, the built-in dependencies or libraries, right? Import the standard libraries, better. So I need the OS, the operating system. Just increase the font a little bit. And also the date time. From date time, I want the date time. I hope the camera is not moving a lot, because that's on, actually the camera is on my laptop screen. Maybe in the future I can have a holder or something to be, not attached to the desk, just to not to move too much. I hope that's not bothering you guys. It's the first time I do this, so yeah, hopefully you're tolerant enough. The second thing I need is the third-party libraries. So import the third-party libraries here. So I need pandas, import pandas as PD. I want to import NumPy as NP. And I want to import matplotlib.pyplot as PLT. That's tongue twister. Matplotlib.pyplot. Try to say that 10 times and you will see that it's difficult. Matplotlib.pyplot. Yeah. All right, so that's as far as the third-party libraries. Also, we need the machine learning part. And that is optional actually. So, the machine learning part here for the logistic regression. So the first thing that we want to do in our application before even we start to code the heart of the app is to locate and load the data set. Right. Let's do like this, and there we go. And let me just, let me go to my folder. I want to copy that from here, from Backblaze, from Tuts, from customer payment analysis. And I'm going to copy the whole folder. Guys, it's important that you would do exactly the same thing. So as you can see, that's the structure. The structure is you have here a folder called data. Inside it, we will have our Excel file. You have your analysis.py or main.py, doesn't matter. Your Python file, right? Those are for the virtual environment already generated when you do ppnv shell. And the README, that's just for my GitHub, and the requirements.txt for the dependencies. So that's everything. Add folder or copy folder. We want to copy the folder. There we go. So you can see that that's the file. You can actually do like this, open with an Excel viewer. If you don't have the Excel viewer, go to your extensions and type Excel viewer, and you'll need just to install that. Just to be able to see the Excel file, not in that format, but in Excel format. So you will open with Excel viewer and you will be able to see all of the data in Excel format. All right, so the first thing we need to do is to actually define the relative path. So I'm going to take the operating system, the OS module .path.join, like in any other application that requires grabbing data from any external file. We need to always join the folder with the file. So we need to join the folder's name is data and the file's name is dummy invoices.csv, right? And we're going to save or just declare a variable called data path, and we'll save in it all of this information. Then we want to read the CSV, yeah, that's right, the CSV file into a pandas data frame. So I'm going to declare that variable data frame, and we're going to take the pandas module dot a method called read CSV, and you can see here that we have more than formats. So you have read table, read Excel, read statistic or statistics, I'm not really sure, HDF, clipboard, feather, HTML, even JSON, ORC, and so on. So pandas gives you the ability to read any kind of data from any kind of file. And we're going to pass inside here the data path. Then let's go ahead and print everything, but let's just make it clean. So on a new line, let's do like this. These are the row data. I want basically to show the first few rows so you can see the row structure, basically. Everything, all of the columns. So I haven't actually showed you the columns that we have. So the columns that we have is, just open with the Excel viewer. Take a look here. So you have the customer ID, because every customer has a number, customer ID, the customer name, obviously, the invoice number or the invoice ID. Then we have here 3 different dates. The invoice date, which is the date of issuance of the invoice. Then based on the payment terms and the contract between the customer and the supplier, you will need to have the overdue date. So let's say that our invoice date has been issued, right? This invoice for Kim Group has been issued in the 2nd of March. It's going to be due on 16th of April. So that's almost a month and a half, right? That's 45 days. So the customer should pay before the 16th of April. And contractually, you can actually charge the customer for extra fees or penalty or anything of that sort. And the payment date for Kim Group was on 15th of April, which means that Kim Group has met the obligation and paid before the overdue date. And sometimes in commerce, we can encourage the customers to pay even before the overdue date by giving them a special discount. So in the payment terms, we can say that N, which is the number of days, if you will pay in the first, let's say 10 days of the whole period of 30 days or 45 days in that case, we can give you 3% discount. Or if you pay before the overdue invoice date, we will give you a special discount of 5%, let's say. So again, it depends on the business and the relation between, and of course, the risk of the customer and the relationship between the customer and the supplier. You have, not all of the customers are the same. You have Group A, Group B, Group C, depends on the risk and the financial insolvency of each customer. So this is just in short. So now we're going to actually show the first few rows so you will see what we're talking about, but I want to have that header and then we will print the data itself. So from the data frame, I want the head. So we can actually write here head. like that. All right. And let me just show you, just make like that. Let's do Python main.py. It's reading, that's why it's taking time. And Python is slow. It's not like C or Rust or any systems programming language. All right, congratulations. We have our data finally. I know it took some time. Let's just do like that because I need just to show you that it has everything, all of the data. You see the customer ID, the name, the invoice ID, the dates, the amount, and the status. Okay, that's what I didn't show you in the Excel file. That also we have the invoice amount naturally, and also we have the status. So if the customer pays before the overdue date, its status on time, obviously, and for example, here we have 17th of August is the overdue date. The actual payment date is 19th of August, which means the customer is delayed for 2 days, has two days delay for payment, that amount. Right? Makes sense. Awesome. Now let's move on for the second step. We just take that, make like this, and make like that. All right, so the second step we have is to ensure the correct data types. And that's very important for compatibility. If we will not do that, this is just a check. We can go ahead and start writing our KPIs functions. But I want to make sure that the data types are proper and correct. So I'm going to show you how to do that. Sometimes I will look here and I will look to the camera, so don't be confused. I'm new to working with cameras, so yeah. So let's just make like this, and let's say ensure the correct data types and compute the derived fields. All right, so that's step number 2. So step number 1, we have printed the data. Step number 2, we want to ensure that we have the correct data types. So first of all, I want to convert the date columns, the 3 date columns that we have. Oops. Those date columns, the invoice date, the due date, and payment date, from string, because that's in a form of string data type, I want to convert it to date time. So here we can say converting the date like columns from string to date time. Right. So I want to have the 3 dates. The first one is invoice date. The second one is the due date. Let's just like this, due date. And the third one was the payment, the actual payment date. All right, and all of that, we're going to store it in a list and assign it to a variable called date columns. So I'm going now to iterate through this list, the date columns. So we're going to say for column in date columns. So I'm going to iterate through the 3 date columns, the invoice date, the due date, and the payment date. And then what I want to do is I want to use the pandas module dot a method called toDateTime. And we're going to pass inside the data frame subcolumn, right, for each column. And we have a second argument, which is the errors. Now for the errors, I'm going to give it a value of coerce, not a value. Coerce actually turns all of the invalid dates into NAT. How it's written, NAT, like that. This right here, that is the pandas null for dates. That's all. It's just a second argument. So just make my phone silent. Sorry for that. So data frame column, and the second is the errors. The second argument is the errors, and you have the choice between course and race. So we're going to actually say course, and we're going to store all of that in data frame sub column equal to pd.datetime and so on. Right, so this is the iteration for each column. What else we need? We need to create a Boolean flag for paid. So to create that, I'm going to take the data frame sub is paid. I'm creating that actually is paid. And that's going to be equal to the data frame sub, the payment date, the actual payment date, dot not NA. So this is a Boolean flag for paid versus unpaid based on whether the payment date exists or not. And by the way, you're going to find the code in the description below, heavily commented, so don't worry about the comments whatsoever. So I just don't want to interrupt the flow every second writing a comment. So yeah, if you have any questions, guys, don't hesitate to ask in the comments below. I do my best always to answer all of your questions. Now, what I want to do is to compute the number of days between the overdue date and the actual payment date, just to understand how many days the customer has paid in delay after the overdue date. So to do that, simply we're going to just declare a variable called today, right? And that is the pandas module or library dot a class, I believe that's class, right? Yeah, timestamp. So it tells you here that timestamp is pandas class, and it's the equivalent of Python's datetime and is interchangeable with it in most cases. And with that, I want to access a method, which is the today method. And we want to normalize. And if you will check out the pandas website for the normalize method, it will tell you that it converts times to midnight. The time component of the datetime is converted to midnight. All right. And this is useful in cases when the time does not matter, length is unaltered, and the time zones are unaffected. So we're going simply to use that. Let's get back to our code. There we go. So that is today. We need to use today for the paid invoices now. So for the paid invoices, I'm going to have another variable, and I'm going to call it effective payment date. So effective payment date, and that is equal to data frame, and we have here the payment date, and we want to fill NA with today. Now, what have I done here? Simply, I just checked for the paid invoice, and I have used the actual payment date. And for the unpaid invoices, today here is used just to compute the current lateness. So what I've done here actually is that I've created this today variable that is basically pandas.timestamp.today. That's today's date simply. And we have normalized it just for midnight stabilization. And then I have used it for the fill NA method, or in the fill NA method. And what is the fill NA method? If you will check out the pandas website, it will tell you here that this is a method actually to use for filling holes in a re-indexed series. And that's exactly what we are doing here for the data frame sub payment date. So that is as long as the data frame sub is paid, but I also need data frame sub days overdue, is overdue, overdue amount, and invoice month. So I'm now don't forget the main purpose of what we're doing. We're actually checking that all of the data types are compatible and correct, to not have any anomalies when running the tool. Now, the next element that we need is the days overdue. And the days overdue is simply equal to the effective payment date minus the due date dot days, right? So that makes sense. That will give us the days overdue. So data frame sub days overdue is equal to the effective payment date. Let's just minimize a little bit. Minus data frame sub due date. And we're going to say here dot dt dot days dot clip, and lower is equal to 0. Wait, hold on. There's something wrong here. There we go. So that is simply the data frame sub days overdue. And here, by the way, I've mentioned that clip lower equal to 0. That means that not less than 0. The days are not less than 0. So basically, an invoice is considered overdue if the days overdue is more than 0. So once the overdue date is passed by 1 day, that means that we have this element or this variable is overdue. So data frame is overdue. That's gonna be equal to data frame days overdue more than 0. Also, for convenience, we will compute a numeric overdue amount proxy. So if overdue, the whole invoice amount is going to be considered at risk. Again, that is very important for management or for you as an analysis, and you will need that kind of analysis to take any preventive measure in the future. So I can write here if overdue, the whole invoice or invoices can be considered or are considered at risk. Most important in any tool, guys, is that you don't just have data or an output. You need to know how to use the output, how to think about the output. And that's the job of any analyst. Any analyst will take the data or the outcome of that tool, analyze it, understands the numbers, understands, in this case, the risk, and will report that to the management to take any necessary action. So now we will need data frame overdue amount. I'll say here NumPy, and I need a method, a very important one, called where. Where is basically takes the arguments are conditions x and y. So if the condition is met, so where true, you can see here, where true yield x, otherwise yield y. So the condition that we have is if data frame sub is overdue is true, so data frame is overdue is true. In that case, I want to yield x. You can see here, it's in green even, right? So to yield x, that is basically the data frame sub invoice amount. So if it's overdue, I want to have the overdue amount. So data frame sub overdue amount. Overdue, or it's not invoice amount, sorry. So data frame sub invoice amount. And if y, simply we'll put 0.0. Right, so that's the data frame sub overdue amount, guys. Hopefully that makes sense to you. And finally, I want to extract month here. That's for grouping, basically. So the data frame sub invoice month, and that is equal the data frame sub invoice date dot date time, and that's a property, by the way. dot a method called toPeriod, and a period, that's a method, and this method will take the month because we need the invoice month. So toPeriod month in double quotes like that, and just let's print everything. So let's do data type check, and I'm going to have my data frame dot data types. All right. Again, you can use a Jupyter notebook, and if you want to use a Jupyter notebook, you will have, instead of main.py, you will have main.ipymb, I believe. Yeah. Now in Python, in Visual Studio Code, you can have that. You will write your code here, and you will click on play to execute that cell or group of cells, or run all to run the whole script, and it's going to give you the same exact results. But for now, I'm going to delete that. Yep. All right, so let's go ahead and check what we have. Let's do like this. Python main.py. Somewhere we have an error, date. What is date? Oh, that is due date. I also didn't understand why due date was not always, being auto-completed. I didn't figure it out, just to make it cleaner. And now we have our data type check. So we have the three first are objects, customer ID, the customer name, and invoice ID. Then we have the invoice date, that is date times 64, correct. The same thing for due date and payment date, so that is proper. All of them are date times 64. The invoice amount is float 64. Status is object is paid, that's the Boolean flag. Days overdue, integer 64, is overdue is Boolean indeed. Overdue amount, float 64. Invoice month, that's period. And the D type is an object. All right, so looks fine to me. Now let's go ahead and start writing our application. All that is just the main nuts and bolts that are very important just to make the application work. Okay, so let's go ahead now and have our KPIs. So let me just copy here from here. Let's do this. And let's change that. Exploratory analysis, that is the KPIs functions. The first KPI function that I want is for the top customers, or getting the top customers by total overdue amount. All right, so let me define a variable called top overdue, and that is equal to open parentheses. And let's see what we'll have. We'll have the data frame, and we want to group by, and open parentheses in a list. And what we'll have here, first of all, the customer ID, and also I want the customer name. Not only that, but also I want to set as index to false, and that is for the overdue amount. Dot sum, so we're going to add all of them, but also I want to sort the values in a descending way, so from the higher to the lower. So sort values, and we're going to pass here overdue amount, and ascending is set to false, which means that descending is true. So now simply I want to print the top overdue dot head, and you're free to print the number of the lines that you want. I mean, you can print the top 5, the top 10, the top 20 as you want. Depends on, again, the size of the company, what management want to see. For the sake of simplicity, we're going to print the top 10 customers. Let's just have a header here, and let's say top overdue customers. These are the top overdue customers that we need to show to management. All right, let's try to run that. And there we go. We have here indeed the customer ID, we have the customer name and the overdue amount. And you can see that this is indeed in a descending order. So the highest overdue amount we have is for Hill LLC for $16,450.09, and so on and so forth. These are the customer IDs, but these are the number of the calls are just attached to it. I mean, from 0, 1, 2, 3. This is all hypothetical. You will have, if in your Oracle system or SAP system, you will have a proper customer ID number. Same thing for invoice ID, and you will have real business data. All of these are dummy data just for demonstration purposes. All right, awesome. So that is the first KPI that we need. The second KPI that we need is the average payment delay. So only for paid invoices. So let's just do B. And we can say here, average payment delay for paid invoices. So I need the data frame is paid, right? So I need the data frame is paid, and we're going to copy that. And let's say here that this is paid. And don't forget to add data frame to wrap it around the DF is paid. So this is the paid invoices. Now, I want to have or define my delay days. And the delay days simply is going to be equal to the actual payment date minus the due date. So paid here, sub delay days is equal to paid sub payment date minus paid sub due date. So the payment date minus the due date will give us the delays date, or the delay days, by the way. Delay days, yeah, there we go. And we need that in days. So that is paid sub delay days. These are the delay days. Now, we will need to use the paid delays in our average delay. So we're preparing to get our average delay. So the average delay variable is equal to open parentheses, and let's work on that. So paid dot group by, we want to group that by, first of all, I want the customer ID. Also, I need the customer name, just to know who did that, who hasn't paid on time. And the index here also will set it to false. And all of that sub delay days. And here we will not say sum, we'll say mean. And also I want to sort the values, delay days, and in a descending order. Right. And also I'm going to just, let's borrow this. And we can say here something like average payment delay. That is for paid invoices, right? And also we can, instead of the top overdue, we need the average delay. And also we will, just for consistency, and we're going to be consistent, we're going to print also the first 10 customers. Let's do that. And there you go. The delay days you have here, number one is Flores PLC. That's the higher, almost 11 days delay. Lee Smith, Foster Stone, Vance and Sons, Webster Smith, and so on. Goes all the way to 3 or almost 4 days. So we have the top overdue customers, we have the average payment delay, but also we want to have the overdue amount by invoice month. So let's go ahead and work on that. So that is C, and we can say here overdue amount trend by invoice month. So that is actually very simple and very easy to do, because only we need to just to group the invoice month, right? That's it. So I'm going to declare another one, declare another variable called overdue trend, and that is equal to the data frame dot group by, and we want to group by the invoice month as index is set to false, and that is for the overdue amount, right? And now we're going to add that, sum it, right? And also sort values by invoice month. And that's it. That's everything. We need just to print that. Maybe I can also borrow this, all right? And that is simply the overdue amount trend. And this is by invoice month, right? We can have the first 10, we can have the first 15 if you want. And don't forget to change the average delay for the overdue trend. There we go. Let's try that out. Awesome. The invoice month and the overdue amount. Awesome. So we have here grouped by the invoice month, right? And year, right? Because we have September in 2024 and September in 2025. And notice that nothing is sorted from the biggest to the smallest, because we want to concentrate here invoice month. That's our metric. That's our criteria, the invoice month. Overdue amount trend going from September 2024 all the way to September 2025. All right, so the last thing that is remaining for us in the KPIs block is the status distribution. We said that we have 3 different statuses. We have on time, we have late, and we have unpaid. On time, which means that the customer has paid on time before the overdue date, or on the overdue date itself still counts. We have late status, which means that the customer has paid after the overdue date, and unpaid, still outstanding and unpaid, and the customer hasn't paid it for X reason. Maybe the customer is waiting some credit note, there is some sort of anomaly in the product itself, so he's waiting for, he has sent the debit note just for analysis by customer service, and they're waiting to have a decision whether we will issue a credit note or a withdrawal letter. So it depends on the situation, really. Therefore, it is very important to check the status distribution and to see what is going on. The on time, the late, and the unpaid. So how we will do that? We will use the power of conditionals. We will check out if the status in data frame dot columns, which means that if we have found the status column in the columns. Note here that if you're going to work with your own data set and you will not have the status column, we're going to see else. We're going to see what to do if it's not found. But if it is found, I want to say that status underscore counts, that is the variable, of course, that we're declaring, equal to data frame sub status dot value underscore counts, and that is a method to count drop NA equal to false. If you will check out in the pandas again website, it will tell you here that removes the missing values. All right, so you can always check the methods and the explanation. The best teacher for you guys is not me. The best teacher for you is to read yourself and do your own homework. I mean, watching a tutorial and coding along is good, but you also need to do your part. You need to read a book, you need to check out the documentation, you need to search, because this way you're going to cement these information in your head and you're not going to forget. I dare you that you won't forget if you will do your own work. Else, we're going to derive a simple status if we didn't find, if not present, simply. So in that case, I'm gonna say status counts is equal to pandas dot series. We're opening parentheses and braces, and I'm going to have the 3 status. So I'm going to say here on time is set to integer, then we'll open 3 parentheses, okay? Then data frame sub is paid. Now I'm going to concatenate that with, just do like this, concatenate it with open parentheses again, with the tilde, with this small symbol on the left upper corner of your keyboard, this tilde sign. Data frame sub is overdue, and just 2 parentheses dot sum method to sum it. That is the on time. For the late payment, we're going to have also integer, again 3 parentheses, data frame is paid, and we're going to concatenate that with, we need just 1 parenthesis out, and concatenate with the ampersand, and we'll open parentheses, data frame is overdue, and 2 parentheses out dot sum again. And finally, for the unpaid, that is in case you don't have the status column in your file. So I hope you will have it because it's really important, but in case you don't have it, we're going to just set those 3 lines, this else block. Again, with the tilde, data frame is paid, and we're going to say here sum. And I see this red squiggly ugly line that I hate. Class here. Oh, I forgot to do like this. All right, comma after each status. Okay, on time, comma, late, comma, unpaid, and you don't need to put any commas after the unpaid. That is it. That is our status distribution. Now let's go ahead and print that. Let's do like this, status distribution, and let's print it by saying status counts. All right, let's see. Awesome. Now we have in our file 44 late cases, on time 41, so that's almost half and half, and unpaid 15. All right, guys, so the last thing we have here is the visualizations with Matplotlib. Now, I'm not sure about the logistic regression, the machine learning part. It's optional. It's not necessary. But if you want to see it, please let me know in the comment section below, and I will create a follow-up video to show you how to use the logistic regression algorithms to predict the late payments. And I believe and by the way, it's very interesting, and by the way, it's very interesting to do. So yeah, now let's move to the fourth element, visualization with Matplotlib. Awesome. Note that we will have one figure per chart, so we won't have any explicit colors or just styles, just to keep it simple. The first one, so we can see here that is for A. The first one is going to be the bar chart. I apologize for that's our neighbor who is happy with his new motorcycle, so I'm very sorry if that makes too much noise. Plot.figure. Next we have the top 5. So you can have top 10, but because the chart itself, it will not, I don't want it to be overpopulated. So you can have top 5, and we can say here top overdue dot head 5. Then we will need that for the plotting. So plot.bar, and we will use top 5, and we have here the customer name, and also top 5 the overdue amount. Awesome. I need a title. Title here we can say, the title here we can say top 5 customers by overdue amount. Excuse me. I also want the X label on the X axis, and that's going to be the customer on the X axis, the horizontal, and on the vertical, the Y axis, Y label, I want to have the total overdue amount. Overdue amount. Right, so also I need the X ticks, and have here rotation equal to 30 and equal to right. And let's have tight layout. And finally, we'll show that. So let's just run it and see what will happen. We have here on the X-axis customer, total overdue amount. Okay, so that's per amount, and that's per customer. And that's consistent with the data that we have here, because that is the first customer with 16 plus 16,450, which exactly matches. Right. Awesome. So that is as far as the first chart, the first bar chart that we have. Also, we can have line chart, we can have pie chart. So let's do so again, we're going to say plt.figure. Also, I want to convert the period to timestamp, month, the month start just for plotting. And for that, I want the X, and the X is equal to the overdue trend sub the invoice month. And that's going to have the date time dot to timestamp. To timestamp. I don't know, it's not catching it. To timestamp. Maybe something wrong I'm doing? No, I don't believe so. Overdue trend. Yeah. The same thing for Y. I need the overdue trend, but instead of the invoice month, I need the overdue month, but I don't need that. Right, so plt.plot x and y, and marker is set to O. Also, I want the title. Let's give it a title of, let's say, for example, overdue amount trend by month. Right. Also, I need the X label. We'll put on the X axis the month. And also I want on the Y axis the total overdue amount. Right. And also we will have tight layout, and we'll show it. And by the way, there is a mistake here. That is not the overdue month. That is the overdue amount. Right. That's as far as the Y. So just for proper plotting. So let's run that and see our line chart. So that's the bar chart. Fine. If we will close this, it should, there is another error, plot title equal to. I apologize for that, guys. Let's run that again. I think I'm hungry. Close this, and there we go. We have our line chart. That is by month, and that is by overdue amount. Awesome. So we will have here for C, and that is going to be the pie chart. That's the last one. For the pie chart, it's actually less hectic. So I want to have here plot figure. I will check out if isInstance, and isInstance is a method that takes two different parameters. So the first parameter is the status counts object, and the second argument it's whether class or tuple. So that is pandas.series. If that is true, I want plot.py, and I will pass inside here status counts dot values labels equal to status counts dot index, and we want to name the slices, and for that we're going to use AutoPCT. If you will go to Matplotlib, you will find that here we can pass a function or format string to AutoPCT to label slices. So we're going to do exactly like here. All right, so AutoPCT is equal to $1.1f%. All right, and that's basically it. And we'll have also a title, and we'll say here invoice status distribution, and we'll have here the tight layout and showing everything. So you understand by now that the pie chart is for instances, the line chart is for the overdue amounts, and the bar chart is used for the top 5 customers. So the different KPIs, we can visualize them in 3 different types of charts. Let's run that and see if we will have any error. So that's the first one for the top 5 customers. The second one is for the overdue trend over time. And the last one, we have here an error AutoPCT. Let's check out. Then have the same one here. We can take it actually from here. Let's copy this. All right. And let's do like that. But it's still complaining. Or not. I'm not sure. Let's see together. That's the first, that's the second, and that's the third. All right. I've actually omitted an extra percent sign here. So you need 2% sign. 1 at the beginning and 2 at the end. All right. And there it is, guys. Simply on time, you have 41%. Unpaid, you have 15%. And late, you have 44%. And that's basically everything. This is our application, guys. It is very useful, very simple to write, to be honest. And again, guys, if you're interested to know how this simple machine learning part is done, please let me know in the comments below. Originally, I was not going to write any machine learning, algorithms in this application. I wanted it just to be a tool or a template to be used for whatever data that we have regarding the customers and the payments and the overdue payments and the amounts and the top 5 customers for overdue amounts and so on. But yeah, the machine learning part will help us to predict whether an invoice will be late or not. And again, it's very important, very crucial for management to know and understand that. And even for you as an analyst or process lead or team lead or even end user to be able to understand what can be expected in order to take the preventive measures. Let me know in the comment section below if you're interested in that, and I'm going to create a follow-up video showing you how to do this machine learning part. And with that, thank you so much guys for watching, and I will see you in the next video. Till then, stay safe and be well.